theory of parallelogram proof using resolving forces. So in the previous video, we have discussed what is the theory of parallelogram. Basically, if you have two forces acting at an angle, concurrent forces here like this, alpha, then the resultant would be the, if you parallelly shift these two forces, P1 here, P2 there, so then the resultant would be there, would be the diagonal of these parallelogram. So that's what the theory of parallelogram says. Now, what we're going to do, we'll use the force resolving technique to prove this theory. So this is P1, this is alpha, this is P2. So we can resolve this force P1 in this direction, which is going to be then P1 cosine alpha. So this is everything along x direction. And then we can resolve these forces along y direction. P1 sine alpha. So summation of Fy, everything in the y direction is P1 sine alpha. So we can use that Pythagorean formula to calculate the resultant, which is basically the r squared. The resultant would be all summation of forces along x direction whole square plus all summation of forces in y direction whole square. So from there we can calculate the resultant. Now fx is P2 plus P1 cosine alpha, then whole square plus y direction force is P1 sine alpha whole square. So simply we can expand this, P2 square plus P1 cosine alpha square plus 2 P2 P1 cosine alpha. This is basically a square equal to b square, no, a plus b whole square formula. So that is a square plus b square plus 2ab. That's what we did. This is the a plus b whole square. So we resolve that piece here. Plus P1 is square sine is square alpha. So we can simply do P2 square plus P1. We can take P1 common. P1 is square. So cosine is square alpha plus sine is square alpha. Basically adding these two pieces right here. Plus 2 P1 P2 cosine alpha. So we can write P2 is square plus P1 is square. As you know, sine is square alpha plus cos is square alpha is 1. So P1 P2 cosine alpha. So that's the resultant. We have found this exact same piece in the previous when we apply the cosine law to prove this theorem. Now the force has both directions, magnitude and direction, so we have to find this direction. So out of this triangle, similarly what we have found in the previous proof of using the cosine law, same thing here. So we can simply write R1, so this is going to be then 180 minus alpha sine 180 minus alpha is equal to P1. It's going to be sine theta. So if you solve for sine theta, it's going to be basically P1 sine 180 minus alpha is sine alpha divided by R. It's not R1, just simply R. So you can use this formula to calculate the theta